Hello everyone. In this lecture I shall discuss the linear differential equations. A differential equation, coming to the definition, a differential equation is said to be linear. You see, its order is anything, right? And here the dependent variable is y. If the dependent variable y and its derivative y dash, y double dash, so on are of degree 1, okay. No product of y and oblique or its derivative terms present, means there should not be y into y dash, there should not be y into y, okay. No product of the derivative terms present, and there should not be transcendental functions of y and oblique or its derivatives, okay. There should not be log y, e to the power y, like that. So coming to some examples, dy by dx is equal to kx square, right? So here the degree of this equation is 1 here, the degree is 1. Order is also 1 here, dy by dx present. Yes, it is linear. Yes, it is linear. Coming to example 2, you see here the degree is 2 here, so it cannot be linear. It cannot be linear. The order is 1. Now coming to this is here in equation 3. It is dy by dx, means the order will be 1, right? The degree will be 1, but the presence of e to the power y, it is a transcendental function, right? It is transcendental in y, so it is not linear, okay. Now coming to another example 4, y d square y by dx square. Here the order is 2 d square y, and the degree is 1, but it is not linear. It is not linear because we have a product here, okay. We have a product of y into this, product of this into this, so it cannot be linear. Now coming to example 5, y square dx plus 3xy dy. So here it will dy by dx, means the order will be 1, the degree will be 1, but it is not linear because there is a y square term here. You see, no product of y and oblique or its any other derivatives, and no transcendental functions of y and oblique or its derivatives occur, okay. Next, coming to example 6, it is a PDE. Y is a function of xt. Okay. So del square y by del t square is equal to a square del square y by del x square. The order is 2, second order derivative present. Here the power is 1 here, okay. Yes, it is linear. Now coming to another differential equation, dy by dx whole square is equal to d square y by dx square plus 1. Now coming to the order, the second order derivative is present, the order is 2 here. Now before finding the degree, we should make it square, okay. And prior to that, because the dy by dx square is present, okay, again we need to remove the root over. So because of this, the degree is 1 here, because the power of d square y by dx square is 1, but it is not linear, okay, but it is not linear, okay. Then coming to dy by dx plus pxy is equal to y to the power n qx, okay. You see here it is a product of y term here, right? So you see the order is 1, the degree is 1, and because of the y to the power n, it is linear if n is equal to 1, then there will be no product, and not linear if n is equal to 2, 3, 4, so on, okay. And also if n is 0, it's okay. Then if n is 0, then also okay, there will be no y here, okay. So these are the examples of the linear differential equation. Students are usually get confused with the definition of linearity. So 3 things you have to remember: the degree must be 1, and there should not be the product of y and oblique or its derivatives, okay, and oblique or its derivatives. Thirdly, no transcendental functions in y and oblique or in its derivatives, okay. So these are the standard examples of linear differential equation. Now coming to the linearity of first order and first degree differential equation, and we'll solve it here. Now the present topic of discussion is the linear differential equation of first order. Needless to say first degree, because linearity means the degree is 1. Okay. So the standard form of this, it is the solution of linear differential equation of first order and first degree. So now coming to the working rule. Consider a differential equation. Consider a differential equation of the form. Your standard form is this, you mark it, dy by dx plus pxy is equal to qx. Okay, you see, this is a function of, p is a function of x, there is no y here, q is a function of x. So this is the standard form, okay, standard form what we are going to discuss. So consider a differential equation of this form. Let it be my equation 1. Consider a differential, and it is consider a linear differential equation of the form. Okay. Consider a linear differential equation of first order and first degree of this form. Now coming to the working rule. In step 1, you find integrating factor. Okay. You must be sure that you see there. This coefficient here is 1 here. Okay. If it is not 1, then we divide it and make it 1. Find integrating factor if is equal to e to the power integral px dx. Okay, you just find the integrating factor. And secondly, step 2, the general solution is y into integrating factor. Okay, is equal to, in the right hand side, integral of qx into integrating factor. In right hand side you multiply integrating factor and integrate it, and plus some constant of integration is there. Okay, so the thing is that we have to first bring it in standard form, and we have to identify what is p and what is q. Be sure that this coefficient is 1 here. Okay, so then the general solution is this. Let us solve some examples. Now let us solve the following 3 linear differential equations. Coming to solution 1. Okay, you have dy by dx, solution 1, dy by dx plus y by x is equal to x square. You see here, this differential equation is of the form, dy by dx plus pxy is equal to qx. Okay, let it be my equation 1 with what is here, px. You see, px is 1 by x here, and qx is x square. So you find the integrating factor. Integrating factor is e to the power integral p dx. This e to the power integral 1 by x dx. Thus this is e to the power log x. So e to the power log x. So here this is x only. Okay. So now coming to the general solution. Thus the general solution is given by y into integrating factor is equal to integral qx into integrating factor dx plus some constant c1. Okay, so that means here y into x is equal to, right hand side here, x square into x dx plus c1. So that means here xy is equal to, it is integral of x cube is x fourth by fourth, plus here there is an integral constant and here there is a constant. So we combine them to get it c, right? So this is your answer. Now coming to example number 2, solution of 2. Let 1 plus x square dy by dx plus 2xy is equal to 4x square. I have told you that this coefficient should be 1. So first you divide it throughout. Okay, if you divide it throughout, so that means your dy by dx plus 2x by 1 plus x square y is equal to 4x square by 1 plus x square. You see now it is your px and it is your qx, is not it? So this is a linear differential equation. It is a linear differential equation. This is the standard form. So now we find the integrating factor. So what is your integrating factor? Is e to the power integral px dx. So this is equal to e to the power integral 2x by 1 plus x square dx. You see the derivative of the denominator is in the numerator. E to the power integral d of 1 plus x square by 1 plus x square. Okay, so this is your ln 1 plus x square, e to the power ln 1 plus x square, and e and ln inverse of each other. So this is 1 plus x square. So the integrating factor is 1 plus x square. Okay, now coming to the general solution. Thus the general solution is given by y into integrating factor is equal to integral qx into integrating factor some constant c1. So this implies your y into 1 plus x square is equal to qx in the right hand side is 4x square. Okay, 4x square divided by 1 plus x square. Okay, it is 4x square by 1 plus x square, and the integrating factor is 1 plus x square and integral dx plus c1. Now if you integrate it, so this will be this and this cancelled. It is 4 by 3x cube plus some constant. Here there is a constant, here there is a constant, added together is c. So this is your answer. Okay, this is your answer. Or if you like, you can divide it here. Now coming to the third problem, solution 3. The question is sec x dy by dx sec x dy by dx is equal to y plus sin x. Similarly, as I have told you, we need to make this coefficient 1. We divide it. So dy by dx is equal to 1 by sec x is cos x into y, and your sin x by sec x, it is plus sin x by sec x means cos x. Okay, so you bring this to this side. So your dy by dx minus of cos x into y is equal to sin x cos x. Okay, so now this is your p, and this is your q, is not it? So you write the integrating factor. This is a linear differential equation, right? First order linear differential equation of our standard form. So what is the integrating factor? Integrating factor is e to the power integral p dx. So this is e to the power integral minus of cos x dx. So integral of cos x is sin x, e to the power minus of sin x. Okay, so now you are coming to the general solution. Y into e to the power minus sin x is equal to integral of q is your sin x cos x into e to the power minus sin x dx plus some constant c1. Now if you put the sin x is equal to t, then cos x dx will be your dt, is not it? This will be your dt. So you put sin x is equal to t, implies cos x dx is equal to dt in the right hand side. So this implies y e to the power minus sin x is equal to integral, this is t e to the power minus t dt plus constant c1, and you apply by parts here. So integration by parts, t integral of this e to the power minus t minus of, and put a negative sign, the derivative is 1 here. Integration of this is minus e to the power minus t, again 1 minus e to the power minus t. Okay, then plus the constant. There is a constant of integration with c1, it comes to your c. Now substitute the value of t, it is minus of sin x e to the power minus sin x minus of e to the power minus sin x plus c. Now this is divided throughout, so that means y is equal to here minus of sin x, and it is minus 1 plus c. Okay, see, and this is also multiplied here, e to the power sin x. Okay, so this is equal to c to the power sin x plus sin x minus of sin x plus 1. So this is your answer. Okay, now sometimes we see a differential equation is not linear in y, but if you reverse it, keeping x as a dependent variable, it becomes linear. Let us see such cases. So here the standard form of the differential equation is dx by dy plus pyx is equal to qy. What we did? We just reverse x and y. Okay, just we interchange x and y. If you compare it with this, we just reverse it. So here you see, this was the standard form. We just reverse x and y, right? Okay, so just we interchange x and y. So what is the integrating factor then? Likewise, the integrating factor is e to the power integral py dy. Okay, then the general solution is x into integrating factor is equal to integral qy into integrating factor dy plus some constant c1. So let us solve some examples. So coming to the solution of 1. So here dx by dy will be tan inverse y minus x by 1 plus y square. Okay, so that means dx by dy, bring this to this side, it is plus 1 by 1 plus y square into x, and let it be the remaining terms are here, tan inverse y by 1 plus y square. So you see, it is linear here. It is of the form dx by dy plus pyx is equal to your qy, is not it? Is equal to your qy. So you see here, we have taken p, capital Q have taken. So this is my q, this is my p. So what is my integrating factor? The integrating factor is e to the power integral py dy. So this is e to the power integral dy by 1 plus y square is e to the power tan inverse y. Now coming to the general solution. X into integrating factor e to the power tan inverse y is equal to, in the right hand side, here qy is tan inverse y by 1 plus y square into e to the power tan inverse y dy plus some constant c1. Now you may put here tan inverse y is equal to t. Okay, put tan inverse y is equal to t. So that means the tan inverse y derivative is 1 by 1 plus y square dy is dt. Okay, so this is your dt here. So this is equal to t e to the power t dt. So now integrate by parts. So this is t integral of e to the power t, g to the power t, negative sign, the derivative of this is 1, the integral of this is e to the power t, there is a constant c2 and already there is a constant c1, this merged together to give you your c. So what is the value of t here? T is here tan inverse y, so this is equal to tan inverse y e to the power tan inverse y minus of e to the power tan inverse y plus some c. In the left hand side, it is x into e to the power tan inverse y, x into e to the power tan inverse y. Okay, so now you multiply this e to the power tan inverse y divided throughout. So now if you divide this, so this implies here x is equal to tan inverse y minus 1 plus c e to the power minus of tan inverse y. So this is your answer. But it cannot be here linear in y. Okay. Now let us see one more example. So now you see it, you divide this, so that means here dx by dy plus here x by y ln y is equal to here 1 by y. Okay, so I can arrange it, just it is dx by dy plus 1 by y ln y into x is equal to 1 by y. Okay, so this is my p of y, this is my q of y. Okay, so now your integrating factor is e to the power integral of 1 by y ln y dy. Okay, so now putting ln y is equal to t, ln y is equal to t, it is 1 by y, dy is equal to dt. Keep in your mind that ln y is equal to t, so 1 by y dy is equal to dt here. So it is dt by t, it will be here e to the power dt by t, it will come in this form. Okay, so here the integral will be of the form e to the power integral of dt by means e to the power ln t. Ln t means ln of ln y. It is, this integration will be, just I am writing the answer, e to the power ln of ln y. Okay, ln of ln y. So now e and ln is reverse of each other. So this is your ln y only. Log y to base e is your ln y. Okay, is your ln y. So now this is your integrating factor. Integrating factor is e to the power ln y. So coming to the general solution, here x into ln y is equal to, in the right hand side it is your 1 by y into ln y dy plus some constant. Okay, now you integrate it, putting ln y is equal to t likewise. So putting ln y is equal to t, it will be this will be your dt. Okay, so t dt plus some constant c. So this is your t square by 2 plus c. The value of t is ln y. So this is ln y square by 2 plus c. Now this ln y is divided here. So this implies here x is equal to, will be equal to half ln y plus c by ln y. So this is your answer. Okay, now let me to ask you some assignment problems. So coming to the summary, a differential equation is linear in the dependent variable if it should be of degree 1. The degree of the differential equation should be 1, and there should not be the product of the dependent variable with dependent variable with derivative with derivative. So that's why it is called dependent variable and oblique or its derivatives. It should not be present. Again, there should not be transcendental function in the dependent variable, log y, e to the power y, sin y, if y is a dependent variable. Sometimes if we interchange x and y, then it becomes linear. Okay, you see the assignment problem 1, 2 and 3. Assignment problem 1, 2 and 3. So you have to bring here your dx by dy, then only you will able to make it linear, right? In your 4 and 5 and direct dy by dx. In these 3 problems you have to take x as the dependent variable here in 1, 2, 3, and these 2 problems we have to take y is the dependent variable here. Okay, unless you interchange x and y is independent here, y is independent here x is independent here in last 2 problems, and these are the initial value problem. Okay, so you should solve these problems and you should refer some standard book to solve many more problems. Okay, unless there is a practice of much problems, you cannot be able to solve the problems. So at this juncture, my appeal to all of you that if you find this lecture is interesting and helpful, please like and subscribe to this channel, and it will boost my motivation to upload subsequent lectures for your benefits. So thank you all. Have a nice day.